let's check out today's problem of the day. Looks like the sum of two numbers is 90, and their difference is 16. Find the two numbers. All right, so we're thinking of numbers that add up to 90. That's what the sum means. And their difference is 16. That means we're going to subtract them and get 16. We want two numbers that will make that true. All right, so let's talk about this problem a little. Let's take a look at it. First of all, there are many numbers that will add up to 90. Okay, there are so many numbers that will add up to 90. And there are also infinite combinations that will subtract and give me 16. But only one will do the 90 and the 16 simultaneously at the same time. This is what we're going to call a system of equations problem, all right? Sometimes you hear it called simultaneous equations because, like I said, they have to work x and y, whatever two variables are that we're looking for, the two numbers, they have to work simultaneously. They have to work together. They have to work in the system. Oh, there's so many ways we can describe what we're going to look at. But you heard the word system, you heard simultaneous. Let's talk x and y. How about it? So first of all, I'm going to call two numbers here. Not really very creative on this one, folks. We'll say x is the first number, and y will give us the second number. How about that? And actually, we're going to go with y being the smaller, all right? So we'll put the second number right there. Because basically, we need to ask ourselves, what are we looking for? We're looking for two numbers, all right? So we've got to find two things. We do know two clues, and that's, by the way, we have to have two clues in order to find two situations. Because the first clue, like I said, you can find infinite amounts of numbers that are going to add up to 90, okay? And when we start adding positives and negatives, there are even more. And if you want to throw in a fraction, because we didn't say really integers here, although these probably are going to come out that way. I hope they are anyway, all right? But even if we have fractions, decimals, etc., there's still many, many, many ways to get 90. In the same way, when we subtract, there are many, many opportunities for 16. So we want to narrow it down to one, exactly one. That's the game plan. That's the game plan. So here we go. We're going to take x and y, and we're going to add them together, and the sum tells me they're going to add up to 90. I can already see some of you at home going like, man, I'm glad he didn't give us a negative on something there. Well, we could have had a negative. That would have definitely made it a lot more entertaining, I'm sure. But that's okay. That's okay. We've got a good enough problem here as it is. And our difference, well, let's take it. I said x was going to be our larger and y is going to be the smaller, so we'll do it like so. And equals to 16, all right? You say, well, Ernie, could you have written y minus x? Certainly. We didn't really identify these as being larger or smaller, but it would have switched y to become the larger. So it's 6 and 1/2 dozen the other. We're going to get the right answer, and it's not 6 or half a dozen, all right? Let's see how we're going to do this. This is a system where elimination is saying, take care of me here. Let's do this. Let's work with elimination, which means we're going to add the two equations together. Why? Because the y's will eliminate themselves. They will cancel out. I've got a plus y and a minus y, which is very good news for me, all right? So we're going to add x and x, and we're not going to get x, folks. Got to remember that. When we add an x plus an x, let's adding 1. I'll put it right there, plus 1, and that's going to be 2x. Now you say, well, Ernie, that was so easy. I knew that. And a lot of you do. But you know what? My students so many times get excited when they see something like this. Oh, this is so easy. And they write x plus x gets x. All right? Careless mistake. Want to avoid them. All right? And so, as we said, the y's, say goodbye to them. That's why we like doing elimination on this. And we're going to add 90 and 16 together. All right? 90 and 16 together. That gives me, I believe, 106. You could probably check for me out there in the phone room, but you know, that's the way it goes. We'll divide now to both sides. Use a nice little division property because that's 2 times some number. So we're going to divide, and at this point it's very easy. Divide 2 into 106. Looks like x is 53. I don't know 53 what, it's just 53, all right? So we're going to say that's our first number. Hope it's right. Now you say, well, Ernie, what do we do to find the next number? I would go back to the x plus y. We know the numbers have to do what? They have to add up to 90. So I would go back to x plus y equals 90, and I would put 53 in place of x, all right? So here goes the 53. We tack on the y, and it equals 90. Subtract your 53 out because we want y by itself. We want y by itself. So we're going to subtract 53 from the left. We'll subtract it from the right. And we're going to end up with y equaling 37. Now, I know they add up to 90. The question is, will they subtract to give me 16? I hope they do, because that means we've got the right answers, and we should. So off to the side here, let's go through it. Let's see what 53 minus the 17 is going to give us. How about it? Did I do that right? No, it's 37, right? I'm jumping the gun a little bit. I want 16. I think we're going to get it now. Let's get that, reduce that down to a 4. We'll borrow and put the 13 right there. 13 minus 7, I see a 6 popping up. That's good. And 4, there it is. There's your 16. So, my friends, these two do check out. Don't know where 37 came from. Actually, 37 is there. I don't know where 17 came from. But that's your problem of the day amid all the interesting twists and turns we take here